the natural language processing task. So next important questions in this lecture is about more advanced topics such as prompt tuning, in context learnings, and also instruction tunings and others. So first, why do we need prompt tuning? So for standard model tunings, we have a pre-trained model, and then we perform the fine tunings based on this pre-trained model. So the disadvantage is that because the current pre-trained models, they have a lot of parameters such as 11 billions of parameters. So after the fine tuning, for each task, suppose we have three tasks A, B, C, and then we separately fine tuning the task for these three different tasks. We will have three different models. So this fine-tuning approach is parameter inefficient because during deployment, we have to maintain three different models. And we have observed that these three models all have the same number of parameters, and the number of parameters is very large. So the prompt tuning is to address this limitation that we instead of fine-tune all the pre-trained model parameters, we only fine-tune a small collection of prompt parameters append before the input, and then we will perform prediction. So for example, in this case, suppose we have three tasks A, B, C, and then we also have like some number of labeled examples associated with each task. And then we will append a small prompt associated with each task. And then we will only fine-tuning the prompt parameters itself. So by doing this prompt tuning, we will only need to fine-tune a very, very small amount of parameters. And more importantly, the pre-trained model parameters is shared across tasks. So in this case, we only need to maintain a single pre-trained model. Now, questions about like prompt tuning, such as what's the like goal of prompt tunings, and how do we perform prompt tuning, such as the definitions of prompt tunings and how do they do it. The second is why do we perform the prompt tunings? For example, what's the advantage of prompt tunings compared to the full parameter fine tuning? So this figure has illustrated the advantage of full parameter tuning. So compared to the full parameter tunings, we only need a single pre-trained models instead of many fine-tuned model. And the pre-trained model itself is shared across all the tasks, so it is parameter efficient. The third question may be that like every technology has its advantage and disadvantage. So the limitations of prompt tuning or the disadvantages of prompt tuning. So it is obvious that prompt tuning is when they transfer to the different domain that is different from the pre-training data set, it may not be perform well because we only fine-tune a very small amount of parameter. So the transferabilities will be limited. For the like in-domain task, it performs well because we already have a very good feature extractors for the in-domain task. So in this case, the pre-trained model itself has already can already like extract a very good feature, but it does not perform very well if the domain is very different from the pre-trained. Okay.
So if we have like the learn prompts, right? Can we use that to initialize for another task?
You mean after the fine tuning, you use it
So
for?
we have task A, task B. We have to learn
Yes.
prompt for task A.
Yes.
Can we initialize that to prompt tune task B?
Yes.
So
Yes, you can.
we can. It's better. Like,
but depends on the data set, so we cannot for sure it can help. Sometimes it may be not helpful because if like there are some study do that for transfer learning. The transfer learning does not always help for the performance. So sometimes it may be harmful because the source domain knowledge may be very different from the target domain. So in that case, it will be like rigid to transform the source domain knowledge to a target. So in this case, it may not help. Yeah. Okay. Uh, so the second branch, very important branch, is called in-context learning. So in-context learning, it is like appears after the GPT-3 comes out because for large pre-trained models, they have pre-trained on very large scale corpus. So they have already contained lots of useful knowledge. So after that, prompt has appeared as a very important component for large language model. But this in-context learning is different from prompt tuning because in-context learning, we don't need to perform any gradient updates. So in-context learning, suppose this is a very simple example. Suppose the instruction is please classify the movie review as positive or negative. So instead of fine-tuning on this example, we can simply provide several examples. This can be served as a demonstration to the language model. This is similar to the human learning. Like we provide some examples for them to study. Then they will perform like a similar task. So for these techniques, we don't perform or update the parameters. We only need to provide several demonstrations to the large language model, and then they will predict the class label. But there are several also similar to the prompt tuning, and they also have its advantage and disadvantage. So for example, the question will be like, what's the advantage of in-context learning compared to the prompt tuning and full fine tuning? So obviously we have observed that in-context learning don't need any gradient updates. We only need to provide several demonstration example. This is a big advantage, but this also is a disadvantage because in context learning, we have to provide high quality demonstrations to the prompt and incentive for the large language models to perform this kind of task. So its performance will heavily depend on the format of the input examples and its quality. For example, as we have discussed in a lecture, some large language models only accept some specific format to the input. If we change the format of the input, the performance will change a lot. It can either decrease or increase the final performance.
Question.
Mm,
Is it
okay.
the same as peer shot prompting?
Yes, it's the same thing but a different name. And we should emphasize it is different from the prompt tuning. It's two different things. Yeah. Hmm?
Prompt tuning is basically just like fine tuning, but on like a small set
Yes.
of parameters.
Yes. The next. Hmm?
Sorry, to interrupt. I don't know if you talk about like LoRa methods.
I actually briefly talk about this.
Could you talk a little bit about like how LoRa differs from like prefix tuning, because they're
Yeah.
very similar, right?
Yeah, so LoRa is basically like it will be append to like several layers that are considered as important. So for example, tensor layers or some like fully connected layer. So it will decompose the full matrix multiplications as like a low rank matrix multiplication. So roughly this,
Okay.
yeah.
Okay, so LoRa is like the attention layers, and then prefix tuning, would that just be like a linear layer, like at the beginning?
So I don't quite remember. So you can just search a lecture after that. Yeah. Next is the instruction tuning. So instruction tuning is to combine the several previous discussed techniques. For example, instruction tuning is to address the limitations of in-context learning because for in-context learning, we don't perform any gradient updates. The parameter itself is static, but it cannot guarantee the performance on unseen task. So the instruction tuning is to enhance the models like in-context learning by pre-training on lots of instruction fine-tuned data set. So suppose we already have a pre-trained language model. Suppose we have only a decoder-based language model. It can generate a sequence, and after that we will fine-tune lots of tasks. So in this case, it is not fine-tuned on a single task, but it is will adapt to many different tasks, and we will perform maybe thousands of this kind of instruction and output pairs. After that, we will perform the evaluations on different unseen tasks. For example, the first step is collect the samples like instruction and output. Suppose the instruction is please answer the following question: what is the boiling point of nitrogen? Then the answer is here. And similarly, we can collect a math reasoning task. Suppose the question is answer the following questions by reasoning step by step. And we will also have its corresponding answer. So by collecting this instruction and output pairs, we will have lots of this kind of fine-tuning task. So during the evaluations, we will evaluate on unseen tasks, such as can Geoffrey Hinton have a conversation with George Washington? So this kind of a reasoning task. So in this part, we will talk about what is the goal of instruction tuning, compared to in-context learnings, what questions does it address? So basically, the goal of instruction tuning is to improve the model's instruction following capabilities that will align with the human's intention. So compared to the in-context learnings, we perform gradient updates to improve its instruction tuning, so it can achieve a better performance and better in-context learning capability. The last very important topic is about reinforcement learning from human feedback and direct preference optimization. So this is also very important fine-tuning techniques for large language model. So the basic motivation of reinforcement learning from human feedback is that standard full supervised fine-tuning, it only address token level loss functions, but does not consider human preference in the entire corpus. So to address high level humans preference, the reinforcement learning from human feedback address this limitation. So there are 3 steps. This is important to remember. So first is we use a human written demonstration data. We will train a supervised policy. This is also called SFT. And second is based on this supervised fine-tuned policy models, we will collect human preference data to improve the model's fine-tuning capabilities to align with humans' intention. The third step is we will train policy models based reinforcement learning based on the reward models learned during the second step. So the reward model itself training is important. So here we will test about your understanding of training the reward models. How do you design the load functions? So for example, we have several pairs of preference. How do you learn the reward model? And we will also talk about the policy like how to learn the policy with respect to the reward models with reinforcement learning. So first is the reward model learning.